you for making some time to join us for the masterclass of how research shapes the world long before we notice it. From our School of Engineering at Rensselaer Polytechnic Institute. We are here joined by faculty and researchers, and I'm really, really excited about this masterclass and what we will share for you. So as you are exploring RPI and thinking if this is the right institution for you, we hope by the end of this presentation, you will get more excited to move forward with your desire and application to come in and join this fantastic institute. But before we start, I just want to introduce myself. Oh, there's Georgia from Kutaisi, Georgia. Hello, hello, Lana. I just want to introduce myself. I will be your host. My name is Blerina Polovina. I'm currently the AVP of International Partnerships at U.S. Partnerships here at InUni. My journey in international education has started about 20 years ago, but even before that, and I really connect with when I hear student stories, I am a former international student. I did come to U.S. to study and life happened and I became here, and now I'm excited to connect with institutions, but mostly to hear the stories from students who have joined in institutions in U.S. and are making some fantastic, wonderful difference in the world of U.S. and the institutions they join and in their lives. I am very excited to join this conversation. And I'm curious to see where people are coming from. What did I say? I saw Georgia for a moment in there. I don't know who else is from, but if you can put in, I'm very excited just to know where you're from. Just because I know in some parts of the world it will be very early morning, in some other parts it will be very late at night. And for you to still make time to join us, this is exciting. But before we start, I'd like to have the opportunity to introduce our panels, just so to know who they are. I will give them a few minutes for everybody to say hello, to share a bit about their story as we move forward into the actual masterclass. And I'd like to start with Dr. Agung Julius, who's a professor and associate dean for the research and graduate program at RPI. Dr. Agung, please let everybody know who you are, and then if you can pass the baton to the rest of our researchers so they can say hello, that'll be fantastic.
Thank you, Blerina. Good morning, good afternoon, good evening. I know that people are joining from all over the world. My name is Agung Julius. I am the Associate Dean for Research and Graduate Programs in the School of Engineering at RPI. My background is in electrical engineering. I've been a professor at RPI for 18 years. And so today we have a few students and a recent former student who's joining us. And we are eager to share our story and our perspectives about engineering research at RPI. Thank you.
Wonderful. All right, so I think I will start with Dr. Ruigzi. I think if you want to just say hello and introduce yourself and tell everybody a bit about your story.
Yeah, of course. Hello everyone. My name is Ray Xie, and I recently completed my PhD in electrical computer and system engineering department at RPI. So I came to RPI in 2022, and my research focused on computer architecture, memory system, and efficient computing for large-scale artificial intelligence. So I studied the computing infrastructure behind the AI model, especially how data is stored, moved, and processed. So large AI model requires substantial memory, computing power, and energy. So my work explored compression and system level method that can improve the performance and reduce the resource use. And one of the most valuable part of my RPI experience was learning how to approach open-ended research problem. And I also had the opportunity to intern at Nokia Bell Lab in 2025. That experience helped me to see how research moved from academic idea towards this practical system and industry applications. At RPI, I also benefit from working with faculty and collaborating with other students, presenting research and mentoring junior students. So this experience helped me to develop both technical and communication skills. So my goal is to develop computing system that make advanced AI faster and more energy efficient and more practical to deploy.
Wow. This is exciting. I don't know much about AI unless I just use ChatGPT and Claude. So what you're saying is pretty exciting. Thank you for everything. All right, I'd like to introduce Mr. Jinhan Ren. I believe hello, are you there, Jinhan? I just want you
Yep.
to say hello. You are an alumni already of RPI with a master's in mechanical engineering, and you're currently a PhD student. Is that correct?
Yes. Yes. Can you
All
hear
right,
me?
but please let everybody know a bit about who you are.
Hi everyone. Good morning, good afternoon, and good night. My name is Jinhan Ren. I'm currently a fourth year PhD student, and I did my master in the RPI. So the memory of RPI took me back to the tough COVID time. So I came to RPI at 2021. I graduated my bachelor in 2020, but during the COVID, because I cannot get a visa. So I have to stay in the stay in China and wait for the RPI. Wait for the RPI news master. So I have to take my first semester online in China. So it was a really tough time. But once I come to RPI, I can feel the difference between the Chinese education and the American education. It's really excited for me because it was my first time to actually go to another country to study my to study something. At that time, I was studied my master program about the mechanical engineering. At that time, the first period of the master program was just purely taking a class. And during my class time, I met my current advisor. Advisors actually two advisors, and they tried to get me more into the research rather than the class. So they brought a lot of chance to me. They involved me into some projects. So one of the project is called ARM Institute. It's about the advanced robotics for manufacturing. It's more for try to learn the robotics metal additive manufacturing and try to use the additive manufacturing to build some complex geometry part. And the second project I've done was about the DARPA project. It's a defense project that's trying to embed the sensor into the additive manufactured part. So both of the projects leads me more deeper to the to my major and concentration, which also gained me a lot of knowledges and experience. So, and after the master program, I decided to continue studying my PhD program in RPI and same major, same concentration, and same research topic. Uh, during the PhD program, I also like Dr. Xie mentioned, we can be TA, we can be RA, teaching assistant and research assistant to share our experience and knowledge to the younger generation student. And for my future career plan, I would like to keep exploring the topic as I learned in the PhD program is try to embody the sensor into the smart metallic structures. Trying to figure out if there's some opportunities to let me keep moving on. Thank you.
Well, that's fantastic. I love the introduction, and there's nothing better than hand-on experience. And you can tell from your master studies, that's how that started. And I'm sure you're going to do amazing things in your future career. And the last but not least, Mr. Safal Pathak, I believe you are another alumni of RPI with a Master in Science of Civil Engineering and a current PhD student. If you'd like to say hello, sir, that would be fantastic.
Thank you very much. Hello, everyone. So I am Safal Pathak. So you can hear me, right?
Yes, we can.
Oh, yeah. Okay, I'm Safal Pathak, and I'm a PhD student here at Civil and Environmental Engineering at RPI. So my PhD research is basically about the developing the efficient and advanced computational models for risk and resilience studies of infrastructure networks, especially against the natural hazards. So as a civil engineer, so since this frequency and severity of these natural hazards are increasing day by day, and it is constantly keeping our infrastructure systems and communities at continuous risk. So these types of research has been really meaningful. So I think it's a very great opportunity that I have got here to work under my advisor, who is one of the best. So yeah, really happy to be here. So about my past background, so I am from Nepal, and I did my undergrad back there. And after that, in fall 2023, I came to the United States to join the RPI. And while being at RPI, I recently completed my master's degree around a year ago. So after that, my master's degree, it has been full of learning moments, and I am really happy about how it went. And especially because of that reason, I joined the PhD degree here at RPI even after that. So talking about my experiences so far in master's degree, it has been like I have done the teaching assistant and been a research assistant and attended like multiple conferences, guided the students, conducted the labs, and well, to sum it all up, all these experiences have really shaped myself into becoming even more better in all these academic and professional pursuits. So, and talking about about the PhD, it's going pretty well. And
Okay.
I think in the future, I might want to, I still am ambivalent about what I would do about my future, but I see myself working in the industry for a few years and coming back to the academia to come back because I think
Okay.
I like teaching a lot. So,
That's
yeah.
awesome. So maybe one day you're gonna be running a whole division of yourself, and then more students will join. But thank you so much for the introduction. And as everybody can see, the opportunities at RPI to get involved are there. So you as a student, whenever you decide to join, you will just have to make sure you take advantage of those opportunities. So I'm very excited to hear what the master class will look like for the rest of the hour. But before we begin, just a few housekeeping notes for everybody. The session is being recorded and will be shared with everyone who's registered for the masterclass. Please feel free at any time to submit any questions at the QA um, area of the webinar. We will have a moderate discussion following up the masterclass, and then after that, we will open it to everybody's questions. And if we, for some reason, cannot answer all your questions due to the timing, we will make sure to get back to you through an email, but our goal is to answer as many questions as we can. So please make sure you bring those questions in. And with that, to help us understand how research at RPI shapes the world long before we see its impact, I'd like to invite Dr. Agung Julians to begin today's session. Over to you, sir.
Thank you, Barina. Can you still hear me?
Yes, we can.
Okay, great. This is Murphy's Law. Just as we started the webinar, there's a leaf blower going on right outside of my windows. I have to switch to an earphone and a microphone. So I'm glad that it's still working. All right. So
Working
let me
wonderful,
begin.
sir.
Thank you. Let me begin by giving a little context about RPI. So RPI was founded in 1824. So 2 years ago was our 200th year anniversary. So that makes us the oldest technical research university in the United States, or in North America, actually. And so that history matters because RPI was created around an idea that science, engineering, and engineering should not only explain, fundamental knowledge to the world, but also improve the world. RPI is located in Troy, New York. So this is in upstate New York. We are a region with strong connections to technology, industry, research, and innovation. And so today, RPI, we are an old school, but we continue to invest in areas that are shaping the future on many fronts, including AI, advanced manufacturing, biotechnology, energy, semiconductors, and quantum computing. The picture that you see on the screen, to the left of your screen, is something that we are especially proud of. Okay, so this is our IBM Quantum System 1. We are the first university anywhere in the world to host, this system. It's a quantum computer. It's a big investment, but it's not only a symbolic investment. This system is accessible to all of our students and faculty and staff. It gives our community access to this advanced quantum computing platforms in an academic setting. It allows students and faculty to explore, do research, take classes that are related to this advanced technology. So when we talk about RPI, we are talking about an institution with long and rich history of innovation, but also an institution that is very much forward-looking and continuing to break grounds in new research areas and building the future. Next slide, please. Okay, so this is a picture that I like a lot because I mentioned earlier that RPI is it's an institution with long history, and we can map how the world, technology in the world evolves around us, and how many RPI engineering graduates have their hands in pushing the innovation and advancement of technology around us. So, you see some names and some important discoveries shown on the slide. On the bottom left, you have Ted Hoff, who's an RPI graduate. He invented microprocessor. So you can imagine, this is the technology that enables the digital revolution that happened since then. And then you have a person, Steve Sasson, who invented the digital camera. So the very device that we're using today for communicating is invented at RPI, or was invented at RPI. GPU, which is the workhorse of AI revolution, was invented by an RPI alum. In fact, Curtis Priam was one of the co-founders of NVIDIA. And the latest picture that you see there is Reed Wiseman. He was the commander of the Artemis 2 mission. They just completed several weeks ago of their lunar mission. And so this is showing that, we have big examples of how RPI graduates have impacted the world, from microprocessors to space exploration. These are things that help shape the modern world, the world that we see today. So this is the kind of legacy that RPA engineers are part of. Okay, so we're not only old, but we are also storied and have long legacy of impactful contributions. Now, of course, this is looking back. Looking forward for prospective graduate students, why does it matter? Okay, so this matters because when you come to RPI, you're not only joining a degree program, but you're joining a school with serious engineering tradition, of serious engineering legacy. And so you can be part of that picture. And I can also add that not many schools can say that about their legacy, what I showed you in the previous slide. All right, so now why RPI, right? So, if you are a student, if you're helping future students considering RPI, why should they consider RPI? So you see many reasons that you can see on your screen now. But I can sort of summarize what you see on the screen into three main ideas. So the first is academic strength. So RPI has strong STEM programs with long-standing reputation in engineering. As I explained earlier, we are doing research in computing, science, and technology, and so on. And many examples that you will hear in this webinar would attest to this point. So certainly academic strength is, there's no doubt about that. The second point that I want to point out is research and career opportunity. So that is something that you can also see on the screen. Our students have access to research, internships, co-ops, and so on with many employers and research organizations. So that means graduate education here at RPI is not isolated from the real world. So students work on problems and skills that connect them with industry, research labs, and so on, and that helps them make real impact. And the third thing that I want to mention as a takeaway from this slide is that we are a supportive community, and many of our members are international students or international people. Now, I myself, was not born in the US. I came to RPI 18 years ago, as I mentioned. This is a very supportive community. So many of our students come from outside of the US. Actually, all three panelists that we have here today are from outside of the US. We have offices and programs that support international students academically, professionally, and personally. So we have even student organization where students self-organize and create support structure. Next slide, please. So if I'm to talk about research or RPI, that could be a 1-hour presentation on its own. So I'm not going to dwell on this, but I think it's suffice to say that we are not only the oldest technological university in the country, but we are still going strong. We have more than $100 million in research expenditure. We are a so-called R1 institution. So this is a classification that basically indicates that we are very highly research active institutions. We conduct research in many areas that you could see on the screen. One thing, though, that I would like to mention is that these areas are not separate silos. So we have sort of research connection between areas, and some of them you will hear from the other panelists today. Next, please. All right. So at RPI, research impact is more than just writing papers. Okay, papers, of course, are important because that's how we disseminate our research outcomes to the rest of the world. But research also leads to things such as patents, formation of startup companies, and so on. So this slide shows that RPI was highly ranked on the National Academy of Inventors list of universities with patents. So we have good output in terms of intellectual property. And so to me, this reflects a culture where research does not stop at theory. We also have ideas that move towards application. I myself have a few patents and pending patents working with my own graduate students. And many of us at RPA can say the same. So for graduate students, this is important because what this is saying is that your research, your education may begin at the fundamental research level, but over time, that work can influence a product, a company, solve actual real life problems and so on, and form future technologies. And RPA education allows you to do that. Next slide, please. Okay, so this is also interesting. So I mentioned earlier in the previous slides that our education and research do not stop at theory. This slide shows examples of RPA engineers entrepreneurship. So we have alumni who form or lead companies, startups. These are just small examples of companies that were founded or led by RPI engineering graduates. The companies on the left, international attendants may not recognize the name. So these are, recent startup companies founded by our graduates. So they're showing sort of the more newer examples. The companies on the right are more established, and you probably have heard of them. Just as another sort of class of examples of companies that are led and started by RPA alums. So our alumni make great impacts in entrepreneurship. Next slide, please. Okay, so this is, I guess it captures the typical experience of students who are doing research at RPI. I'm not going to belabor too much on this, but basically the idea is, when you start at RPI as a new graduate student, you may start with, taking classes and doing more fundamental research. So it may not be immediately obvious how, what you're doing is going to lead to innovations and patents and companies and so on. But as you're doing research, you're taking classes, you learn more about the field that you're studying. You'll see opportunities, you'll see problems that need solutions, and that is how our students. That's a pathway for our students to make impact in the world. Thank you, Blarina.
Yeah,
Okay, well,
so
thank you so much. I believe we're going to our first case study, and Dr. Ruixi, I think it's your turn. So please take it over and let us know
mhm.
about your research.
Yeah, thank you for introduction. So my research focus on like how we store this artificial intelligence like AI models. So as I mentioned before, the AI models are becoming very like more capable, but they also require substantial memory, computing power, and energy. So the system demands increase the cost of running AI and make advanced model more difficult to deploy on a what they call like a wider range of hardware. So my research focuses on the computing infrastructure behind these models, especially how data is stored, moved, and processed through the memory and storage systems. So although the user do not directly see this infrastructure, like we just like interact with like ChatGPT or like a Claude or something, but it also has a major effect on system performance and energy consumptions. So I studied the memory behavior to identify where the system spends time and energy moving data. So based on this observation, I developed a compression and system level data management method that is like reduce the unnecessary data storage and data movement while preserving the functionality of the model. So the broader goal of this research is to help AI system run faster, use less energy, and operate on the more affordable hardware. So this work shows how like the research underlying computing infrastructure can influence widely used technologies years before those improvements become like visible to the public. So I think this is all my research introduction. Thank you.
Sorry,
Hello?
I was not aware I had turned myself off, so my apologies. Case two, Jinhan, please let us know what your research was about.
Okay, so let's take a look at the case study too. This case study is based on my research as well. It's focusing on the smart manufacturing and its applications. The key idea of this study is that the research is changing the traditional products and the structures from the passive objectives into the system that can be smart and even alive. Of course, the alive here does not mean the biologically alive. It means that a structure or a part can sense its own condition, collect the data, and provide useful feedback during the operation. Smart manufacturing brings together the several important technologies, including the convergent manufacturing, automation, robotics, data collecting, and the advanced materials. Instead of only making a part with a fixed shape, smart manufacturing aims to create the parts that can communicate information about themselves. For example, a structural component may be able to monitor in the temperature, strain, the damage, or the environmental conditions in the real time. So one important in enabling technology is the additive manufacturing. The additive manufacturing expands the capacity of manufacturing because it allows us to fabricate complex geometries and combine the multiple materials and integrate the functional elements directly into the structure. Compared with conventional manufacturing, it gives researchers more freedom to design not only the shape of the product, but also its internal functionality. So in my research area, this idea is especially important for the smart metallic structures. Metal are what they used in the aerospace, defense, automotive, robotics, and energy systems because they can carry load and also operate in the demanding environment. But however, These systems also need reliable monitoring. So if we can embed a sensor inside a metal structure, the structure can measure its own temperature, strength, or damage state during the service. It will be fantastic. The image on this slide showed examples of this idea. So on the right side, you can see this schematic illustrates an embodied sensor inside a monitor structure. So the sensor interacts with the structure and produces an output signal. So those signals can be utilized to understand what is happening inside the material to make the structure called smart. So on the left and the bottom, those are my research project. So on the top, the top one is the process of metal additive manufacturing. So you can see there's a torch welding and making a cone part. The bottom is the smart metallic structures. Is a smart beam we fabricate by the top technique, and you can see we use the finger to touch the beam, and the beam can feedback you the signal. Oh, it can sense the force you pressure on the beam. So it's really interesting to show how the manufacturing and testing are connected in the practice. This is also why RPI has received the significant support to the advanced smart manufacturing research. So you can see the broader goal is not only just to make the better parts, but also to create the new generation of the intelligent structures and manufacturing systems. So the main takeaway from these slides is that the smart manufacturing is not only about automation or faster production. It is about combining the manufacturing, sensing, multiple materials, and the data collection to create the structures that can monitor themselves and support a safer and even more reliable engineering systems. So this is my case study introduction. Thank you.
Thank you. Quite exciting and very interesting. And all I know is that I go to the store and buy the stuff. So thank you for the magic you all do in the back end to make that happen. And I think we will go in with a case study for the third one. And Safal, this will be you. Please let us know a bit about your research and how it connects to what you're studying. And the ball is on your side.
All right. Thank you very much. Yeah. So my research involves studying the risk and resilience of the infrastructure systems, which I think is a very good example about some of the research that people barely even see. So when people think about civil engineering, I think they often picture about the individual assets like the single bridge or a single building, etc. But if we look from the broader perspective, from a community perspective, then these assets are usually a part of a large interconnected system, such as the transportation system or the power system that essentially support the daily life and the essential services that people rely on. So when natural hazards like earthquakes or hurricanes, they occur, they don't affect just a single system, but disrupt the entire system that the community relies on. So the question comes, as a civil engineers, what can we do about it? So basically we build, and that's one aspect of it. So we build the computational models that can capture the whole story of the disaster. For example, like simulating the hazards, like the hurricanes or the earthquake, we can simulate them. Then we can model the damage to the infrastructure components like bridges. And then we can also model the loss of the functionality. And sometimes we can go even more further, like simulate the recovery process as well. So basically, all these simulations, why do we do all these things, is because this essentially helps the decision makers to guide the decisions. And these decisions might include something like what components to strengthen before the hazard even occurs, or where to invest the limited resources, or something like how to plan the recovery. So to elucidate this even further, so I am linking this with my own research that I have recently done. So as you can see on the right-hand side, you can see the pictures of falling bridges because of the earthquake. So during the earthquake, the bridges are considered to be one of the most vulnerable elements in transportation network, which can disrupt the mobility and emergency accesses. So One way of preventing this kind of bridges before even the hazard would occur would be to strengthen them before the disaster happens. So basically, in our terms, we call it retrofitting. So as shown in the figure below, this is a little bit problematic though. When you are thinking about the large scale transportation network, as seen over here, this is the transportation network in Los Angeles and Orange County. So you can see that the green dots would represent the bridges in the system. So as you can see, there are quite a lot of bridges in the network. So because there would always be like the budget constraints and the financial constraints, you can't retrofit them all before the hazard occurs. So the decision makers have to select the optimal set of bridges to retrofit. So this was our motivation to one of our research works. So the question comes like, which subset of the bridges to retrofit under the limited budget? And the answer would be select those bridges which would minimize the system seismic risk. So based on this motivation, we formulated an optimization problem to solve it. And while doing so, we came across the two computational challenges. So the first was something like, there would be quite a lot of combinations. For example, if you see a network with around 200 bridges and you have the budget to retrofit only 30 of them, then the possible combinations of this would be around 10 to the power 36. And for each of this combination, now you have to run this high fidelity, expensive simulation that takes hours to run for each one of them. So traditional methods would be almost like impossible to do that. So for that, we developed a computational framework by embedding a machine learning model, a graph neural network, into an optimization algorithm, the Bayesian optimization. Although I didn't want to go into the details of that, but however, based on these this computational tool, we address these challenges that I mentioned earlier. So the blue dots here represents like the selected optimal bridges that would minimize the seismic risk of the transportation network. And one interesting thing you can note here is that you can see these red lines, right? These are the possible reasons where the potential earthquake would occur, but you don't know where the future earthquake would occur. So considering all of this, we had created one of the framework for pre-disaster mitigation. So my whole point here is that there are some research so when we implement this kind of research into real practice, and when the disaster happens and infrastructure system still remains reliable and resilient, people might not even notice it. But even though those decisions might have saved the life of many people. So I think this is an interesting thing about how we civil engineers do our works. So yeah, thank you.
Oh, thank you so much. And can I just say, I've never even thought about engineering research to protect people a way we may not notice. But I think every research you spoke about, it's thinking of people without us even noticing. I think at the end of the day, we just do the end result, or we're assuming the streets are taken care and these bridges are taken care of, but it's your research and the hard work that you are doing to make sure we are safe and we're taking advantage of all these great opportunities that come our way. So this is exciting. Thank you so much for sharing your researches. And with that, I think we will go into just some questions that we all have discussed, just to give a more preview to our listeners about RPI and the research opportunities. And I see quite a few questions coming our way on Q&A, then I will open it up. But I believe the first question, can we change the slide, please? Thank you. I believe the first question will be to you, Dr. Agung. How do students learn to work on research problems whose real-world impact may not be visible yet at RPI?
Yeah, thank you, Blarina. This is a good question. So many graduate research problems, do not immediately have clear or and obvious applications, as we all know. So students, when they begin, they may start with working on theory, a model, simulation, something like that, just to get themselves more skillful at the techniques that they will use in research, be more familiar with the challenges in that area, and so on. And so, generally, students learn to work in this kind of environment through, like, you can think of it as research practice, right? So students learn how to formulate good research questions. They learn the research skills. They review the literature. They review essentially the body of knowledge around them to figure out what's already known, what are the open questions, and so on. And this is something that is very important. What I'm about to mention, this is something that students transitioning from undergraduate education to graduate education sometimes have struggle. Is that students, when you transition to graduate education, you need to adapt yourself to an open-ended type of work. So when you are in undergraduate education, you're taking an exam, your professor has the answer to the exam at the back of his or her pocket. So there's nothing is really open-ended. This is just, going through knowledge that has been produced before. But when you're looking at graduate education, especially graduate research, many questions are open-ended. Your professors may not have the idea, and you may have to try different things, and many times you will fail. So failing is part of growth. And so, professionally, students will develop, that kind of understanding and resilience that, even though, when you try to solve a real problem, 9 times you would fail, but the 10th times you get the solution, and you manage to solve a problem that's important to not only to yourself but also to other people. So at RPI, students, do this through mentorship by the faculty, by the research advisor. They gain experience in labs doing experiments. They collaborate with other students and other researchers all around the world, and so on. They learn to publish their ideas. They learn to take criticism of their ideas, and also they learn to evaluate other ideas. So I think the key idea here is that as students transition from undergraduate education to graduate education, learning becomes more active, more hands-on, more open-ended, and I can say more exciting, because the script is not pre-written for you. You get to explore. Thank you.
Thank you. And I will say I never heard of graduate studies being described as an open-ended type of work, but I wrote it down because I think it's quite interesting. And I did heard, I read somewhere it says, if you failed, congratulations, it means you tried. A lot of people never even try. So I think it's exciting to come in an environment where you're coming with an open-ended question, where you can try. And you have a support, a team that supports you, a group of researchers or offices that support your growth. But I think that'll be an exciting environment to grow, that is for sure. So thank you, Professor. And I think the next question will be for you, Dr. Riggsey. Looking back at your RPI experience, what part of research prepared you most for the work today?
Yeah. So this is actually very great question for me, because I just graduated from RPI. So looking back at my RPI experience, so the parts of the research that prepared me most was learning how to work through problems that did not have a clear answer at the beginning. So my research as I mentioned, my research focused on the memory system and improving the efficiency of large artificial intelligence models. So in many cases, the first challenges was not implementing a solution. It was kind of identify the real bottleneck, deciding what should be measured, and design the experiment that could separate a useful improvement from an interesting idea. So that process taught me to break a very complex problem into smaller questions and test the assumptions carefully and revise my direction when the result did not support the original hypothesis. And it also taught me that the research progress is not like a linear. Unexpected result often reveal the most important part of the problem. So these skills continue to shape my work today. the technical knowledge I gained at RPI is valuable, but I think the most lasting preparation was learning how to define uncertain problem, evaluate the evidence, and keeping improving a solution whose real world impact may not be visible in several years. Thank you.
Oh, thank you very much. And I think that's a lesson we can take even in our lives. Identify the bottleneck before you find the solution. Because sometimes in your research, you can find out what you thought was the problem was actually not the problem, and stepping by step. So, oh, this is exciting. Thank you so much. All right. So the next question I do, it's for you, Chin-Han. What does day-to-day research look like when the problem may take years to fully mature?
Hi, this is a very important question because as for me, my research topic is actually a newer growing up topic. Most of the products they currently not yet reaching to the smart this this terminology. So for this question, so in the research, so especially in the advanced manufacturing, my own research. So progress is often very different from what people imagine. So from the outside, people usually see the final result, right? So a working prototype, a published paper, or a successful demonstration. But for us, for the researcher, the daily progress is much more gradual. So it involves many small steps, repeated experiments, failures, redesigns, and careful documentations. So for a long-term research problem, the first daily task is usually to break the large vision into the smaller research questions. So like my advisors always asking me like, Jinhan, what's your research problem right now? For example, if the long-term goal is to create the smart metallic structures with embodied sensors, right? So then we need to ask smaller questions. So how can the sensor survive under the heat of the metal additive manufacturing? How can we protect the sensor without weakening the entire structure? How can we reconnect the metal deposition over a sensor region? And how do we verify that if the sensor still works after the fabrication? So all those questions may become a separate experiments. So one day may focus on designing a sensor layout. Another day we may focus on the preparing a sample and machine a surface, like applying a protective layer or just run a deposition trail. And some other days we may just mainly testing and collecting the data. And other days we probably just do the analyzing why something got failed. So a very important part of day-to-day research is learning from the failure. So in the manufacturing research, failure is not only a problem, it is also information. So if a sensor breaks or it doesn't work, so if that's a coating determinations or if a sensor becomes noisy, or we need to understand the back mechanism about it, right? So was it caused by the temperature, like stress concentration, poor adhesion, or electrical connection issues? So this process helps turn the uncertainties into the engineer knowledges. And another key part is to connect the short-term result into the long-term goal. A single successful test may not solve the entire problem, but it can validate one piece of the pathway. For example, proving that the sensor, if the sensor can survive one manufacturing step is progress. Showing that it can still measuring the strain or the temperature accurately is another step. So over the time and the time, all those smaller validations can become a complete smart manufacturing solution. So the day-to-day research is really a balance between the detailed technical work and also the long-term vision. So researchers need patience, definitely, because the final application may take years to mature, but they also need the discipline. Because every experiment they did, every data set they collect, and every failure they made can contribute to the final larger picture. The main message of this question is that all those impactful research, they all build through the incremental process. So you have to be patient and enduring and also disciplined. The mature technology does not appear all at once, right? So it grows through the repeated cycles. of the design and fabrications and the testing, analysis and the improvement and even the failures. So yeah, that's all based on my experience from my research career. Thank you very much.
Thank you so much. So keywords, patience and discipline. And well, it looks like the day-to-day thing. It's always interesting. Then it's never nothing the same. So that's exciting as well. But thank you for sharing your point of view. I think honestly, the lessons I'm learning here, it's not just research. I think lessons in life that people can take out of all the recommendations you're putting in here. All right. So the last question before we open it up to the public will be to you, Safal. As AI plays a growing role in engineering research, how is it reshaping the way we study and protect large infrastructure systems?
Thank you very much for the question. So I think in my experience, the AI, especially I would say the machine learning in particular, has significantly reshaped how we study the large infrastructure systems. And this is by mainly making the analysis much faster and at a much larger scale. And I think this is one of the most important things, the scaling issues. So it has helped us scale at a much larger scale than before. So at a while not keeping too much of a technical terms, but however, I must introduce those terminologies here. So I think one of the most intuitive thing I could say that has helped a lot in the infrastructure research is the surrogate modeling. So basically, these surrogate models are the machine learning models, which are trained or based on the input-output relationships of the highly expensive computational simulations, so that instead of running them those analysis each and every time, we can just approximate result within a fraction of seconds, which would save significantly the computational burden. So why this matters in the risk and resilience study of the large scale transportation network is because the first, our simulation is very, very expensive. And the second is like we used a probabilistic estimates in these risk and resilience studies. And this does not generally have a closed form solutions. So therefore, what we use is called a Monte Carlo simulation. So at a very high level, this means like you run the same not the same simulation, but you run the simulation again and again to get the expected values or something like that. So like I said, at a very high level. So basically the surrogate models, once trained, they can be used to approximate these expensive high simulations within the fraction of seconds, making the risk and resilience study of large scale infrastructure networks more computationally tractable. And I think the second aspect would also be improvement in the decision making. For example, in the past, when the computational was a huge bottleneck, so many decisions related to infrastructure systems had to be relied upon the heuristic-based methods, like the rule of thumbs. And of course, we know that those would be way too far away from the optimal solutions. So with these faster AI tools, and we can now embed them within the optimization, large-scale optimization problem, like which is essentially what I did earlier and I explained earlier. So those kind of problems becomes computationally tractable, becomes solvable, and better optimization would mean the decisions would be even more better about how we protect the community. And beyond that, I think in the civil engineering, this is my personal opinion though, but I think that we are not looking out for making a significant breakthrough in the AI, but rather we are looking at more of like a methodological transfers, like based on how we formulate the problems. Like if there is like a image related class problems, we can use a generative models like diffusion or convolutional neural networks or something like that. When we have a time dependent problem like simulating the recovery, which evolves over the time, then we can use researchers have used the LSTMs or GRU or something like that. So basically, I think that these models has made our research much more efficient and has helped us to take our infrastructure problems to even more larger scale and helped make us make more risk and resilient informed decisions to protect our community. So that's my thoughts on
Yeah.
this question. Thank you.
Well, thank you. I appreciate it. And I think it's fair to say AI has been used as a tool into
Yeah,
to helping you do the research, but at the end of the day, civil engineers are going to be needed, and AI is not going to replace them. So,
exactly.
because everybody keeps saying AI will steal jobs, and I think that's one of the worst misconceptions. Well, thank you everybody for the answers, and I see quite a few questions that we have from our audience. So I'm going to start asking some of these questions, and hopefully we can cover most of them. As I know, time slot here is 5 minutes, but maybe we can stay just a bit longer. One question that I think I found interesting is, what path or program do you suggest for students to be involved in research that leads to paid patents, industry partnerships, and real-world solutions at RPI? And I think Professor Dr. Angung, I think this may be a question you can answer.
Yeah, so generally we have a lot of programs that lead to that, right? So, I can give you one concrete example. The people that we have here on the panel, they went through programs like that. So Dr. Wishe, he mentioned earlier that he did his graduate degrees in electrical engineering, or rather computer system engineering, and he's working on real solutions. And after he graduated, he's joining a startup, working on the very resource problem that he worked on as a student. um, you know Mr. Jin Han Ren, working on smart manufacturing. um, Within that research group, they have tons of connections with industry because they are solving problems that industry really care about. um, and so, I cannot pinpoint specific programs that lead to that. I think generally, our research programs have that kind of property.
So just have students come in with an open mind, willing to learn and understand, and start getting involved.
Yeah.
And then somewhere on the way, they will find the opportunity that fits what they're looking for to expand on that research that will walk them through the next stages. Thank you.
Yeah.
I do have a question, and anybody who has to answer is, but it's interesting even for me to know, how is AI used differently in research versus how everyday people, just like me, use ChatGPT or Claude? I'm not sure who may answer. Maybe Rui, you
Maybe
can
Rui,
kind
yeah.
of, yeah, I think you're the master of AI in the back end. uh,
Yeah, so for me, I think like the main difference is like everyday user mainly using AI is like ChatGPT or like Claude to just simply like answer a question or like summarize or like generate some idea. But like I think like research AI is used as a what do you call it, like a technical tools to analyze, for example, like a very large data set. We use it to like discover some pattern and generate some like a hypothesis and produce some result that must be reproducible and validated. So we must design we use the term as like a prompt, design some very rigorous prompt for the research. I think that's the main difference.
okay, thank you. Yeah, as all I do is I will take my AI here and just use that. So thank you for doing the fantastic research you all do in the back to make this happen. An interesting question, and maybe Safala will ask you because it's most to do with infrastructure. When studying infrastructure resilience, do students work with real data from past disasters and real cities?
Yeah, I think that is a very good question, I would say. So this is something I myself has struggled with a lot. So the thing is, it would be very much meaningful to work with the real data sets. But in the research, people have been using the synthetic or the assumed simplified data sets, as well as been using the real data sets. But what we especially like to do is to use the real data sets. So, and in United States, especially, I wouldn't say just the United States, but also like Japan, they have been providing the repository for the data sets. Like if you want to get the data set for transportation systems, then you can get the origin, destination, demand matrices for different transportation network free of cost. And also there is like a concept of collaborations, right, in research. So basically, people would be willing to uplift the research by sharing the data among the collaborators. So I think that is one way of doing it. But to give the answer in a very short manner, I think these days the data has been made publicly available for wide range of hazards and the networks. But there are some of the networks for which the data are kept very confidential. So it depends upon the domain. But I would say that I think it would be more substantial contributions would be made if we use the real-time data sets. That's what I have experienced.
Thank you, Safal. I appreciate that. I know we reached that time, so maybe I'll ask one question, and this will be for you, Jinhan, because I believe it has to do with manufacturing. And the question is, what kind of hands-on lab experiences can students expect in smart manufacturing at RPI?
Okay, so that's a good question because I'm working currently. I'm working on this topic, and I know RPI recently just launched a very good center called CSAMS. It's called the Center of Convergent Manufacturing Research Center or something. So this center has so many great resources. So you can, as part of the member, you can collaborate with the all the advisors focusing on different areas of the smart manufacturing. For example, the additive manufacturing, subtractive manufacturing, even biological manufacturing, and also even the nano manufacturing. All those resources, they have different professors that they can help to guide you and also provide you the resources to give you some hands-on opportunities to actually work on this research. We also have the resources for the different background understanding level of the different student. So for example, you just a master student coming with the you don't have a lot of hands-on experience for example. You can have some entry level project that can help you. You can still use those equipment and resources, but you can have a relatively easier project for you to get yourself into the environment. And also, if you already has a lot of experience, for example, you came from the industrial or this sort of stuff, you got a chance to be involved in some higher level research projects. So all those opportunities you can find in the CSMS, as I'm saying. And also you can also, get yourself into the projects from some class, I guess. Yes, there's plenty of opportunities. Yes. Thank you.
Thank you. Thank you, Jinhan. And thank you, everybody. I know we passed 9 o'clock. I am not sure. Do we have time for more questions, panel, or do we want to just have the other and we can answer the rest of the question through an email to all our attendees.
Blarina, if I can make a suggestion.
Yes.
There is one question. Yeah, so the one that Jinhan is
he's typing
responding
it.
to. Yes. So I think that is probably an important question. Like people ask, the kind of support students receive before arrival or first few months. And I think it would be important for the other panelists, being students or recent students themselves, to tell stories about, their experience. Thank you.
Thank you. No, I think that's a great suggestion. So how about we will leave it with this question. So what kind of support do students get before arrival and when they come from your experiences that you can give tips to the future students planning to join RPI? Whoever wants to be first, take it.
So I remember there's a Discord channel that operated by the OGE, I remember. So you can find all those common ask the questions from those Discord channel, and we have RPI has the a professional team that can help manage your for example your house renting or like just make you more comfortable to come to the RPI. I'm pretty sure you can find the Discord channel from the website of the RPI. Search I think it's like OG, but I can definitely search and drop the link in the email if you want. Yeah.
Oh yeah, that'd be great. Well, I want to turn this question a bit more from your experiences as well. You came in the first couple of months at RPI. What do you wish you could have done different, that maybe you give tips, or if you did everything great, that you think, hey, this will work as you come in as a student in the first couple of weeks coming into an RPI. I recommend you do 1, 2, 3, 4 to get adjusted. To a new student, what would you recommend, any of you, that worked for you, or maybe you wish you had done it and passed the lesson to somebody else? Everybody was like, I did everything right. Any tips that you might share? Like Safal, when you joined in, what was your experience on the first few months as you kind of adjusted to the American culture, the American education system, and this whole different, I mean, it's a whole different place, right? And
Yeah.
especially, I know, Jinhan, you said it was the first time ever for you leaving your home country and coming to a whole different country. So those first few months, I'm sure, are a bit culture shock, education system shock, new people shock. Any tips that you would give somebody who's exploring coming from a whole different part of the world that you think may make the transition a bit easier?
I would say it definitely very difficult for the at least the first semester. But my suggestion is don't be afraid. Just make friends. You are always not alone. So we have RPS lots of international students every semester. Uh, they all feel confused. They all feel like a little bit afraid, but they're not alone. So make sure you can go reach to the international student group. You can make friends with the same country you're from, or like a different country, other countries. It's fine because everyone when they first come to United States, they cannot even speak English very frequently. So you guys just stay together and chat, and that also helps. Even helps your English. So
Oh, yeah.
yeah, that's what I'm saying. So don't be afraid. Just make friends, and things will getting better and better.
I mean,
Yeah.
when I started, I told you, Jinhan, I'm a former international student. I'm sorry, Safal, I didn't mean to cut you off. But again, to me, that was my biggest fear. I was so afraid if I start to speak, people would make fun of me because my English was not as good. And then I realized it was all in my head because people were very kind. They were very understanding. So yeah, they're not going to be alone. Everybody's probably feeling the same way, and just go out there and just make friends. Sorry, Safal, I didn't mean to cut you off, but
Oh, no,
please
no, no,
make
it's
your
totally
point.
fine. So yeah, I was just trying to say that I totally agree with what Jinhan just said. Like I too had, I was living with my roommates. There were four of us, and even though I could have spoken their language, I chose not to because I wanted to improve my English. So that helped me communicate even more better. And I think that's a very great tip. And another thing I think I would like to add is like the education system. People coming from since I'm from South Asia, so I know the culture of the education system over there is a little bit more towards the theoretical side. So for those people who are a little bit afraid about how would the study in United States would look like, I would say it would be awesome because that's what my experience has taught me. Because coming from more of like a theoretical backgrounds or something like that, here when I have taken quite a lot of course, like 12, 13 courses so far. So from all these courses, what I have learned is like here is like a perfect balance between the theoretical knowledge and then comes the practical knowledge. Like professors are very concerned about the key takeaways. Like, for example, if I have to give you an example about the structural engineering, because that's my main focus. So back in my country, in South Asian country that I know of, the system is like they will teach you different kinds of methods to solve the same kind of structures. But here, I was amazed that they will teach you the fundamentals and a little bit more and make you strong enough in the fundamentals, and they will give you the state of the art knowledge. Like there is a whole course designed for matrix structural analysis, whole course designed for nonlinear structural analysis, whole course for finite element analysis. And these are all the state of the art things, and these things have significantly improved my knowledge on structural engineering. And I would say that this, I'm not trying to make you more nervous about this, but I'm saying that this will significantly make you more academically sound and make you more prepared for the industry, I think. So it has been a great experience, the learning thing. And it's not as difficult as you think it would be. It's very, very, very attainable. Thank you.
Well, thank you. Yeah, I think, as Dr. Agung said, the graduate program is an open-ended question kind of thing. So you're not going to have the answers here. You're going to have to come and explore those answers, which sometimes, as you said, can be different from other parts of how education systems are. And I appreciate the fact that you said you found people from your region that you could have spoken the language, but you chose to speak English. And I think that's one of the things people are overwhelmed when they find students from the same country. They go into those communities because they feel safe. But I always tell students, you came to US to expand. So go out there and meet people. And so force yourself to speak in English. I think that's a great suggestion. And I know we passed 10 minutes after our discussion. So with that, I just want to say thank you to all the panelists for joining us, for sharing your knowledge, for sharing your experience. It is quite exciting and clear that if you want to join RPI, you will have that hand-on experience. You will have all these opportunities to grow as an individual, as a student, as a researcher, and as a future professional, and you will have a community that will assist you in every step of the way. And with that, if you have any questions to all who are still here, please let us know and we will come back to you and we will try to have the answers to the other questions that we were not able to answer when we send us our follow-up summary. But for now, thank you, everybody. Wishing you all the best with the researches and the PhD experience. And I hope to get to see some of your great stories sometimes in the future. But for now, wishing everybody a wonderful day, a wonderful evenings, and hopefully we'll see you at RPI. Thank you, everybody. Bye-bye.
Thank you.
Okay.
Thank you.